Electricity is one of nature's greatest forces. And by the middle of the 20th century, we'd harnessed it to light and power our modern world. Hundreds of years of scientific discoveries and inventions brought us here. But it would take the eccentric genius of one man to unlock the full potential of electrical power. In the winter of 1943, Nikola Tesla looked out across the Manhattan skyline for the very last time. Tesla had been born into a world powered by steam and lit by gas. But before his eyes, he saw a new world, a world transformed, a world powered by electricity. His world. Frail, lonely, and still mourning the death of one of his beloved pigeons, this extraordinary and eccentric genius knew that his life's work was done, and he lay back on his bed to die. It would be 3 days before anyone found his body. Just over 200 years ago, early scientists discovered electricity could be much more than simply a static charge. It could be made to flow in a continuous current. But they were about to discover something profound, that electricity is connected to magnetism. Harnessing the link between magnetism and electricity would completely transform the world and allow us to generate seemingly limitless amounts of electrical power. This is the story of how scientists and engineers unlocked the nature of electricity and then used it in an extraordinary century of innovation and invention. But not before one of the most shocking engineering rivalries in history was finally laid to rest. Our story begins in London at the beginning of the 19th century with a young man who would further our understanding of electricity as much as any other. On the 29th of February 1812, a 20-year-old self-educated bookbinder called Michael Faraday came here to the Royal Institution of Great Britain. He was surrounded by the great and the good of the academic world, and he was about to listen to one of the greatest scientific minds of the age. Faraday, the son of a blacksmith, had finished his formal education when he was just 12 years old. He would never get to university, but he wasn't finished with learning, as he was fascinated by science. Faraday worked long and hard during the day binding books, but in the evenings he would read whatever scientific literature he could lay his hands on. He loved learning new things about the world, and he had this constant desire, this passion to understand why things were the way they were. Reading scientific papers was one thing, but to really satisfy his craving for knowledge, Faraday was desperate to see the experiments themselves. And he eventually got his chance when he was given a ticket to attend one of the last lectures of England's greatest chemist of the time, Sir Humphrey Davy. It was to change young Faraday's life forever. After watching Davy, awe-inspired and full of ideas, Faraday knew what he wanted to do with his life. He was determined to dedicate himself to furthering science. And that's just what he did. Within a year, Davy had appointed him as an assistant at the Royal Institution. With Davy as his patron and, well, his boss, Faraday studied all manner of chemistry. But what would inspire his greatest breakthroughs were the invisible forces of electricity and magnetism. In 1820, both were being studied by a Danish scientist, Hans Christian Ørsted, who'd made an extraordinary discovery. He passed an electric current through a copper rod and brought it close to a magnetic compass needle and saw that it made the needle rotate. To Ørsted, it was remarkable. He'd shown for the first time that an electric current can create a magnetic force. He'd bound electricity and magnetism together. Today, we call it electromagnetism, and it's one of the fundamental forces of nature.
Ørsted's discovery sparks off a whole new spate of inventive activity around and about the fields of electricity. You can almost see electrical experimenters vying, competing with each other to find new links between electricity and the other powers of nature.
At the Royal Institution, Faraday set about recreating Ørsted's work, which would mark his first steps to fame and fortune. And through his rigorous research, he concluded that there must be a flow of forces acting between the wire and the compass needle. The device he designed to demonstrate it would change the course of history. Faraday created a circuit using a battery like this, a pair of wires, and a mercury bath. Now the circuit carries on through these copper posts, and this wire hangs freely, it dangles into the mercury. Now because mercury is such a good conductor, it completes the circuit. When the current runs through the circuit, it generates a circular magnetic force field around the wire. Now this interacts with the magnetism from a permanent magnet that Faraday had placed in the middle of the mercury. Together, they force the wire to move. Faraday had proved that this invisible force really does exist, and he could see its effect: circular motion. This beautiful device was the first to convert electric current into continuous motion. Basically, it's the earliest ever electric motor. But